Hello, grade 10. Here, Mr. G. We're going to be looking at the question where we have to complete a table using the periodic table and get some information from the periodic table, okay? This question said complete the table. The table is this one here, that one there, using the periodic table of the element, which you can see here in front of you, okay? Now, this table has the following columns. Element, we're going to start with sodium, we're going to do another three. We have a standard notation. Let's just remember what is standard notation. Now, standard notation, remember you use the symbol of the element with an X. Right on the left top side, you will write the atomic mass, and at the bottom, you will write the atomic number. Just for recalling here, the A is the atomic mass, and the atomic mass is the number of protons, which is Z, plus the number of neutrons, which is N. All right, that is the atomic mass. And here at the bottom, on the left bottom side, we can see the atomic number. This one here, this Z, represents the atomic number. Now remember, the atomic number is the number of protons. Alright, so that is the first information. The X represents the symbol of the element. The first one is sodium. Okay, now let's go to the periodic table and find out sodium. Everyone you're supposed to learn that sodium is Na. So this block is for sodium. Note in the periodic table, at the bottom here, you will have the atomic mass, the relative atomic mass, and we already learned how to calculate the relative atomic mass, okay? And here on top, you will have the atomic number, okay? So the same happens for sodium. The number on top is the atomic number, and the number at the bottom is the relative atomic mass. So for the standard notation, we have that sodium is Na, atomic mass is 23, atomic mass is 23 and is on top left 23, and the atomic number is 11. You can see it there on top, right? So it's at the bottom, is going to be 11. How many protons does sodium has? It has 11 protons, it's the atomic number. How many neutrons? Now, how do you calculate the neutrons? Neutron is going to be equal to A minus Z, all right? And in this case, it will be 23 minus 11, which is equal to 12. So sodium has 12 neutrons. How many electrons does sodium have? Okay, this is a neutral sodium. Remember, when the atom is neutral, if it's neutral, I'm going to write here, neutral, so the number of protons must be equal to the number of electrons, and therefore it is 11 electrons. Now, let's go now to the electron configuration. Now, the electron configuration, remember, we are going to represent the electron as the energy level as numbers and the orbitals as letters, and that will be 1s, 2s, 2p, 3s, 3p, and 4s. All right, and the number of electrons in each orbital will be taken to the exponential number. So, for example, we have to represent a total of 11 electrons. Now, remember, the orbital s can hold 2 electrons, up to 2 electrons. Okay, and the orbital p can hold up to 6 electrons. All right, S can hold up to 2 electrons, P can hold up to 6. Okay, so here 1s, 2, 2s, 2, 2p, 6. Now we have 2 and plus 2 is 4, plus 6 is 10. We have 1 electron behind, so it's 3s, 1. So that will be the electron configuration. This is not needed here. It's up until there. That will be the electron configuration for this specific question. This one here is the electron configuration for sodium. Okay? Let's go to the next element. Let's go to see the next element we are going to do. And this time it's going to be a ion. Alright, so we're going to be looking now at magnesium ion. Now we have to explain a little bit less because most of the explanation is already given there. So now we're going to see magnesium ion. Now remember, we already done it, that magnesium ion is Mg2 plus. Now, what is the meaning of the 2 plus here? What is the meaning of the 2 plus? This here have a meaning. That means the 2 electrons are gone. It lose 2 electrons. Okay? So when we check the total number of electrons of protons, now they will have minus 2 electrons. So we go to the periodic table to magnesium. Here is magnesium. Remember, we are representing magnesium ion, but the symbol is the same. The mass is 24. Mass is going on top here, so it will be 24. That doesn't change, and the atomic number for magnesium is 12. So it is 12. How many protons does magnesium has? It has 12. How many neutrons? It has is equal to A minus Z is equal to 24 minus 12. It is equal to 12 neutrons. Okay, now how many electrons? Okay, it's supposed to have 12 if it was neutral, but it is not neutral. It did lose 2 electrons, therefore it has 10 electrons. It has 10 electrons because it lost 2. Alright, that is why it is a 2 plus, because it was 12 but lost 2 electrons, now it has 10 electrons. Now, the electron configuration, we are going to 1s, 2s, so now we can already do it fully. So now we have 1s2, 2s2, 2p6. There we have the 10 electron. So this one here is the electron configuration for magnesium ion. Let's do one more. Let's do now, for example, fluoride ion. Now, fluoride ion is also one that you know. You work at the beginning of the year about that one. So this one is fluoride ion. Now the symbol for fluoride ion is F minus. Okay, it's F minus. Let's go to the periodic table to find out some information there. F is here. Alright, so what is the atomic mass? The atomic mass is 19, and that is the number on top. 19. What is the atomic number for fluoride? It is 9. So you come here, and then here is 9. Alright, now number of protons. How many protons does fluoride ion has? It has 9 protons. Neutrons is the same. Neutron is equal to A minus Z. A is 19, Z is 9, so it has 10 neutrons. Alright, how many electrons does now fluoride has? Fluoride ion. Now here is the other way around. Here it had 9, but it gained an extra electron. This minus means that fluoride have an extra electron, one extra electron. All right, so now fluoride has 10 electrons because it gained one extra electron. So it has now 10 electrons. Let's go to the electron configuration. It will be exactly the same as magnesium ion. It will be 1s, 2, 2s, 2, 2p6. This is the electron configuration for fluoride ion. Okay, I think this is clear. This is all for now. We see 3 examples of completing a table and getting some information like the standard notation, the number of protons, the number of neutrons, the electrons, and very important, the electron configuration for these 3 elements. You can practice with other elements up to the first 20, and then you can ask any question if you have. Thank you very much for watching, and good luck.